Welcome students. Today we are entering into a very interesting topic, that is on hypothesis testing. Especially this topic is going to be fundamental for coming lectures. So you have to carefully, you should understand the class objectives are, first I am going to explain how to develop null and alternate hypothesis, because solving a hypothesis problem is very easy. The most important is how to formulate the hypothesis. Once you are very good at formulating the hypothesis, solving the problem is very easy. Then I am going to explain what is a type 1 and type 2 error, and how this context of type 1 type 2 error is connected with hypothesis. Next we are going to do hypothesis testing when sigma, that is the population standard deviation, is known. Next we will go to hypothesis testing when population standard deviation is not known. Then we will do hypothesis testing for the population proportion. First we will go for what is hypothesis testing. Hypothesis testing can be used to determine whether a statement about the value of the population parameter should or should not be rejected. So hypothesis is nothing but some assumptions about the population parameter. We know that most of the populations which we are going to do is going to follow a particular distribution, for example a normal distribution. So normal distribution having two parameters, one is mean and variance. So we can assume the population mean as a hypothesis, an assumption, otherwise we can have population variance also an hypothesis. The null hypothesis denoted by H0 is the tentative assumption about the population parameter. So whatever assumptions which are having, that will go to the population parameter. The alternative hypothesis denoted by HA is the opposite of what is stated in the null hypothesis. The hypothesis testing procedure uses data from the sample to test two competing statements indicated by H0 and HA. What are the two competing statements is, one is null hypothesis, another one is alternative hypothesis. Next we will see how to develop null and alternate hypothesis. It is not always obvious how the null and alternate hypothesis should be formulated. We should be very careful to structure the hypothesis appropriately so that the test conclusion provides the information the researcher wants. The context of the situation is very important in determining how the hypothesis should be stated. In some cases it is easier to identify the alternative hypothesis first, in other cases the null is easier. So correct hypothesis formulation will take a practice. In this lecture we are going to take some example, and I am going to explain how to formulate the hypothesis, whether it is null or alternate hypothesis. First we will start with alternate hypothesis as a research hypothesis. Most of the time the researchers wanted to prove the alternative hypothesis. Many applications of hypothesis testing involve an attempt to gather evidence in support of research hypothesis. In such cases, it is often best to begin with the alternative hypothesis and make it conclusion that the researcher hopes to support it, because many of the time the researchers wanted to support his hypothesis. So first you have to write the alternate hypothesis. The conclusion that the research hypothesis true is made if the sample data provide sufficient evidence to show that the null hypothesis can be rejected. So if you want to accept your alternative hypothesis, the data which were collected from the sample has to support the null hypothesis to reject it. Next, alternative hypothesis as a research hypothesis. Example, we will see some examples here. An example is, a new manufacturing method is believed to be better than the current method. Assume that in a manufacturing context somebody is proposing a new way of doing work, a new manufacturing method. So we want to test this assumption. So what is the alternative hypothesis? The new manufacturing method is better, because that new method was given by the researcher. Always the researcher will believe that whatever he says is there is a support for that. So first we will formulate the alternative hypothesis, that is the new manufacturing method is better. The null hypothesis just the complement of alternative hypothesis. So the new method is no better than the old method. We will take another example. A new bonus plan that is developed in an attempt to increase sales. Now, what is happening in a organization? So, we are introducing new bonus plan, we are going to see that the bonus has any impact on the sales. So, what is alternative hypothesis? The new bonus plan increases sales. So, first to go for alternative hypothesis. Then what is the null hypothesis? The new bonus plan does not increase the sales. You see that when you look at the null hypothesis, it will say always does not increase the sales, that is why it is called null, nothing has happened, that is the meaning of null. We will go for another example of alternative hypothesis. See, a new drug is developed with the goal of lowering cholesterol level more than the existing drug. So, what is happening? There are some drugs are available to lower the cholesterol, that a researcher has found some drug. So, that is reducing the cholesterol better than the existing medicine drug. So, we will go for alternative hypothesis, the new drug lowers the cholesterol level more than the existing drug. So, null hypothesis is the new drug does not lower the cholesterol level more than the existing drugs. You see that does not. So, this does not represents the null. So, nothing significance has happened, that is why we are calling it as null hypothesis. Then null hypothesis an assumption to be challenged. We might begin with the belief or assumption that the statement about the value of the population parameter is true. So, in the hypothesis testing context, always we will start the problem assuming that the null hypothesis is true. For example, in India, before starting a trial, suppose somebody was accused. So, before starting a trial, the trial will be started assuming that the person is innocent person. You see what is happening, the trial will be starting assuming that the person is innocent, the police has to bring some evidence and they have to say that he is not innocent. When in other countries, the person who is being suspected, he has to prove his innocence. So, it is reverse. So, what is the meaning of this reverse? That even though something has happened, if there is no evidence, that person is free. We then using a hypothesis test to challenge the assumption and determine if there is a statistical evidence to conclude that the assumption is incorrect. In this situation, it is helpful to develop the null hypothesis first. We will take one example of how to develop a null hypothesis. A null hypothesis is an assumption to be challenged. Example, you see look at the label on a milk bottle states that it contains 1000 ml. Null hypothesis is the label is correct. So, mu is greater than or equal to 1000 ml. Another hint is the null hypothesis is nothing but the status quo. In null hypothesis always there will be a equal to sign. The null hypothesis is look at it at a optimistic perspective. If somebody say the bottle contains the 1000 ml, we are assuming that yes, that assumption is correct. So, we formulating the null hypothesis is mu is greater than or equal to 1000 ml. So, alternative hypothesis the label is incorrect, mu less than 1000 ml. You see that the signs are complementary. Since in the null hypothesis it is greater than or equal to, there is a less than. If the null hypothesis is less than or equal to, so the alternative hypothesis it will be mu. If the null hypothesis is equal to, the alternative hypothesis is not equal to. And the null hypothesis always will have equal to sign. Alternative hypothesis never contains equal to sign. The status quo will go to null hypothesis. We have to challenge the status quo, that is nothing but your alternative hypothesis. Okay. You see how the nature of the null hypothesis, the equality part of the hypothesis always appear in the null hypothesis. That means in null hypothesis always there will be a equal to sign. So, when you say equal to means it is equivalent to null, nothing has happened, that is the status quo is maintained as it is. In general, the hypothesis test about the value of the population mean mu must be take one of the following three forms, where mu naught is the hypothesis value of the population mean. You see that the hypothesis may take different forms. For example, mu greater than or equal to mu naught, the mu naught is what we have assumed population mean. You see that the null hypothesis there is a greater than or equal to, so we are writing in the alternate hypothesis less than, because the signs are complementary. So this test is one tailed test, that is called lower tailed test. So how we are calling it lower tailed test is, for example, if I am drawing here, we have to look at the sign of your alternate hypothesis. The sign of your alternate hypothesis is less than mu naught, so it is left tail test. If anything goes beyond the left hand side, we will reject it. See, there is another context, mu h naught mu less than or equal to mu 0. So alternate hypothesis is mu greater than mu 0. Here also you look at this is a less than or equal to, so complement sign is greater than. So it is one tailed, it is called upper tail test. Look at the sign of our alternate hypothesis, it is greater than. So if it is greater than, so it is called right tail test. If anything beyond this point, suppose this is a mean, beyond this point will be rejected. The last one is equal to sign, mu equal to mu naught. So mu not equal to mu naught, this is called a two tail test. So two tail test is, you see that the rejection area will be on both sides. So if the value goes below this, we will reject it, the value goes above this, reject it. What is the meaning of value? I will explain. We will take an example to do a hypothesis testing. A major hospital in Chennai provides one of the most comprehensive emergency medical service in the world. Operating in a multiple hospital system with approximately 100 mobile medical units. That hospital is having 100, not 100, 10 mobile medical units. The service goal is to respond to medical emergencies with a mean time of 8 minutes or less. So the problem is that they have 10 mobile medical units, they have to, whenever there is an emergency, they have to respond 8 minutes or less. The director of medical services want to formulate a hypothesis test that could use a sample of emergency response times to determine whether or not the service goal of 8 minutes or less is being achieved. Look at this problem. The director wanted to test the service goal of 8 minutes or less is being achieved. See, now it is like a alternative hypothesis. The researchers wanted to test whether the service goal of 8 minutes or less is achieved. So what will happen? Now the status quo is 8 minutes or less. So what happened? The status quo will go to null hypothesis. So what is that null hypothesis? The emergency service is meeting the response goal. So no follow up action is required. The another name why it is called null hypothesis is, when you accept null hypothesis, no follow up action is required, no course of action is required. So why we are saying mu less than or equal to 8? Because that is the status quo. So always null hypothesis is looked at a optimistic perspective. So when I say mu less than or equal to 8, you see that the opposite of this, what is that? The emergency service is not meeting the response goal, that is appropriate follow up action is necessary, that is why it is called alternate hypothesis. So mu greater than or equal to 8, you see that here it is a less than or equal to 8, so the sign is complementary, it is greater than or equal to 8. Why we are writing mu less than or equal to? The status quo should go to null hypothesis. Okay. Where the mu is the mean response time for the population of medical emergency request. So we will go to what is the type 1 error. Because hypothesis tests are based on the sample data, we must allow for possibility of errors. Because the conclusion of hypothesis, that is to accept or reject, is based on sample data. So always there is a possibility of error. A type 1 error is rejecting H naught when it is true. As I told you in the court context, somebody is pleading that he is innocent, but the judge is not accepting he is innocent, but really he is innocent, but his innocence was rejected. That is incorrect rejection, that is a type 1 error. The probability of making a type 1 error is when the null hypothesis is true. When the null hypothesis is true is called the level of significance. So, level of significance we call it is alpha, most of the time it is 5%. What is the meaning of this 5% is the probability of incorrect rejection is only 5%. Application of hypothesis testing that only control the type 1 error are often called significance test. Type 2 error. A type 2 error is accepting H naught when it is false. It is difficult to control the probability of making a type 2 error. Statisticians avoid the risk of making type 2 error by using do not reject H naught instead of accept null hypothesis, because in the hypothesis context when we conclude it we will not say accept null hypothesis, we will say do not reject null hypothesis, because there is no proof for that null hypothesis is true. See the context, see the population condition is H naught is true, you see that in the conclusion H naught is true, but see this, when you reject H naught that is called your type 1 error. So, that is called incorrect rejection. You see the other case, the H naught is false, but you have accepted. So, that is called your type 2 error. So, another name for type 1 error is incorrect rejection. For type 2 error it is false acceptance. We can say another example, the producer risk, we call it as alpha. Alpha is called type 1 error, beta consumer risk is called type 2 error. What is the meaning of this producer risk and consumer risk is, assume that I am the manufacturer, I am producer, I am producing shaft. So, whose diameter is, for example, the shaft diameter is say 50 mm. Suppose there a supplier is coming, the supplier has taken some sample from my production lot, then he is rejected my lot. He says that your production level is not meeting our specification, that is 50 mm. There is two possibilities there. The supplier who has the way he is measured is wrong, otherwise the sample which I have kept is not correct. So, that is incorrect rejection. Even though I have quality good products, they have rejected, that is an incorrect rejection, that is called producer risk. So, there is another possibility, assume that I am making only 49 mm of shaft, again the supplier comes, he measured it is 50, it is 49, but he has measured it is 50, then he has accepted my lot. So, that is false acceptance, that is called type 2 error. There are two possibilities, one is the sample which I have kept that meet all his requirements, but my whole lot is not meeting his requirement. So, that means my sample is not the representative of the population, that is one possibility, otherwise the way they have measured it, that is wrong. So, that is called false acceptance, that is a type 2 error. In the next lecture we will see the application of type 2 error in detail. There are three approaches for hypothesis testing. First approach is p-value approach, most of the statistical package follow this method. Second method is critical value method. The third one is confidence interval value method. The confidence interval value method mostly used for two-tailed test. First we will go for p-value approach, that is one-tailed hypothesis testing. What is the p-value? The p-value is the probability computed using test statistic, you should be careful, test statistic that measures the support or lack of support provided by the sample for the null hypothesis. So, the p-value says whether it is supporting the null hypothesis or it is not supporting null hypothesis. If the p value is very high, it will support null hypothesis, we will accept null hypothesis. If the p value is less, it will not support null hypothesis, we will reject null hypothesis. Say we say that what is the test statistic? The test statistics, for example, in the Z context, the test statistic is nothing but this one, x bar minus mu divided by sigma by root n. That is the test statistic for Z test. If it is a t test, this is x bar minus mu s divided by root n. So, n minus 1 degrees of freedom. So, whatever value which you have calculated with the help of sample, that is called a test statistic. If the p value is less than or equal to the value of the alpha, then the value of the test statistics is in the rejection region. I will show you in the next slide. Reject H naught if the p value is less than alpha. Okay. If the p value is very less, it is not supporting null hypothesis, you have to reject it, where alpha is significant level. We will see how to use hypothesis, how to do hypothesis testing using p value approach. The p value approach, the first one is, see, assume that the problem alpha equal to 10%, it is given, okay, this was alpha. So, we have to calculate this test statistics, that is your z value. So, x bar might be given, x bar is the sample mean minus mu is the population mean what we have assumed, sigma value must be given root of n. For example, this value assume that it is minus 1.46. Okay. So, this minus 1.46 corresponding what is the left side area. So, this value is our p value. Okay. How to get this one? So, when z value is minus 1.46, we can get corresponding area of a normal distribution on the left hand side. So, that one we can do with the help of Python. For that, first we have to import SciPy. So, importing library from SciPy, import stats. Then the left side area is say minus 1 point, the left side is z statistics minus 1.46. So, when you put minus this one stats dot norm dot CDF cumulative distribution function minus 1.46, we are getting the probability is 0.07. So, that is nothing but 0.07. You see that this alpha is 10%. So, the p value is less than the alpha. So, we have to, this region is rejection region. So, this region is acceptance region. Beyond this point it is rejection region. So, the value of the p, that is when z value equal to minus 1.46, since we are standing on the left hand side, that is we are standing on the rejection side, we have to reject the null hypothesis. This is left side test, lower tail test, that is I explained. Now, suppose if it is a right tail test, say the calculated z value is 2.29. We got some x bar value, mu value, sigma by sigma value, root n value. So, suppose this is giving 2.29. So, for alpha, assume that alpha equal to 4%, when alpha equal to 4, we have to mark it alpha equal to 4% from the right to left. So, when alpha equal to 0.4%, when z value is 2.29, we have to find out what is the corresponding area towards on right side. So, what you have to do? We can find out 1.75 also, see that when z value is 2.29, so stats dot norm dot CDF will give you the right side area. When you put 1 minus stats dot norm dot CDF, 2.29 will give you the left side area. So, this first one actually it is not required here, because alpha value is directly given here. This is only for proof, this is for testing. Testing how to use from z, this is z value, from that we have find out the probability value. So, now the z value is 2.29. So, we want to know the right side area. So, 1 minus corresponding area that will give the right side area, that is 0.011. So, this area I am saying, this area is 0.0111. Now, look at this alpha. So, the p value is less than the alpha. Otherwise, you see the p value. So, this side is the rejection region, this side is the acceptance region. So, when the p value is 0.01, still you are standing in the rejection region. So, you have to reject null hypothesis. In case if the p value is 0.05, you might have crossed the boundary. After crossing the boundary, you will be landing on the acceptance region. So, you have to accept null hypothesis. Now, we will go to another method, critical value approach for one-tailed hypothesis testing. The test statistic Z has a standard normal probability distribution. We can use the standard normal probability distribution table to find out the Z value with an area of alpha in the lower tail or upper tail of the distribution. For example, we know the alpha value, say alpha value is 0.05. So, this side area is 0.05. With the help of Python, when alpha is 0.05, you can get the Z value. This is lower tail test. For upper tail test, when alpha equal to 0.05, you can find out corresponding Z value. In Python, what you have to do, if you want to know this right side upper tail test, you want to know the Z value, you have to is 1 minus 0.05. For that probability, you have to find out corresponding Z value. Okay. The value of the test statistic that established the boundary of the rejection region is called critical value of the test. If it is, if the 5%, you will get 1.645. Here also minus 1.645. So, this minus 1.645 is called critical region. Rejection rule. If it is a left tail test, reject if the Z value, that means your calculated Z value is less than this minus 1.645, because you will be standing on the rejection side. If it is a right tail test, if the calculated Z value is greater than your table value, then you have to reject it. You see, for example, sigma is known, the alpha equal to 10%. When alpha equal to 10%, corresponding Z value is minus 1.28. This is our critical region. This is our critical region. So, with the help of sample data, you have to find out the Z value. If the Z value is lying on this side, you have to reject it. If the Z value is lying on that side, you have to accept it. Okay. For example, when area equal to 0.1, the corresponding Z value is minus 1.28. I am going back to previous slides, so minus 1.28. Now, we will go for upper tail test. When alpha equal to 0.05, so the right side area is 0.05. So, this side is 0.95. So, when the left side area is 0.95, corresponding Z value is 1.645. If any calculated Z, if this Z value is lying on this side, for example 1.7, you have to reject the null hypothesis. If it is lying this side, you have to accept the null hypothesis. For example 0.95, the value is 1.65. What is the, see we have now we have done hypothesis testing with the help of p-value approach and critical value approach. What is important point you have to note that is, the decision whether to reject or accept a null hypothesis in p-value method is decided by comparing the probability of, what is the probability? P-value versus alpha value. But in a critical value approach, the decision is done by comparing the critical value and calculated Z value. Decision is same, only for comparison purpose, sometimes we compare probability, sometimes we compare critical value, but the end result will be same. So, what is the first step? We will develop null and alternate hypothesis. Step 2, specify the level of significance alpha. This is very important. Before starting of the test, you have to decide the significance level. Step 3, collect the sample data and compute the test statistics. This test statistic may be your t value or it may be Z value. The p-value approach, what will you do? Use the value of test statistics to compute the p-value. If the p-value is less than or equal to alpha, you reject it. The same step for critical value method, use the level of significance alpha to determine the critical value and rejection rule. Use the value of test statistic and the rejection rule to determine whether to reject H naught. Dear students, in this lecture so far what we have seen what is hypothesis, what is a null and alternate hypothesis. We have learnt how to formulate hypothesis. Then we have seen hypothesis testing. In the hypothesis testing, we have seen what is left tail test, what is the right tail test, what is two tail test. Then we have seen the theory of how to test the hypothesis by using p-value approach and by using the critical value approach. In the next class, we will take one problem. With the help of that problem, we will formulate the hypothesis, then we will test the hypothesis with the help of p-value approach and critical value approach, then we will compare the result. And one more thing, one more method that I did not cover in this lecture is, that is testing the hypothesis with the help of confidence interval, that we will do in the next class. Thank you very much.